शिवाजीराव एस जोंधळे कॉलेज ऑफ फार्मसी, आसनगाव. I, Assistant Professor Akash Nalawde, and our today's topic is determination of viscosity. Viscosity. Introduction. Definition. Viscosity is a measure of a fluid's resistance to flow. The SI unit of viscosity is Poisson, that is PI. Its other units are Newton second per square meter or Pascal second. The dimensional formula of viscosity is m0 L-1 T-1. The viscosity of liquids decreases rapidly with an increase in temperature, and the viscosity of gases increases with an increase in temperature. Thus, upon heating, liquids flow more easily whereas gases flow more slowly. Also, viscosity does not change as the amount of matter changes, therefore it is an intensive property. Viscosity formula. Viscosity is measured in terms of a ratio of shearing stress to the velocity gradient in a fluid. If a sphere is dropped into a fluid, the viscosity can be determined using the formula, that is n is equals to 2Ga 2 in bracket change in density upon 9V, where change in density is the density difference between fluid and sphere tested. G is the acceleration due to gravity, A is the radius of the sphere, V is velocity of the sphere. Viscosity types. Viscosity is the measure of a fluid friction to its flow. There are two types of viscosity as follows. First, dynamic viscosity, that is absolute viscosity. Second, kinematic viscosity. Dynamic viscosity. First point. Dynamic viscosity is the force needed by a fluid to overcome its own internal molecular friction so that the fluid will flow. Second point. In other words, dynamic viscosity is defined as the tangential force per unit area needed to move the fluid in one horizontal plane with respect to another plane with an unit velocity while the fluid molecules maintain a unit distance apart. Third point. Dynamic viscosity is also referred to as absolute viscosity in the field of fluid mechanics. Kinematic viscosity. First point. Kinematic viscosity is a measure of a fluid internal resistance to flow under gravitational forces. Second point. It is determined by measuring the time in seconds required for a fixed volume of a fluid to flow a known distance by gravity through a capillary within a calibrated viscometer at a closely controlled temperature. Method to determine viscosity. Capillary viscometer method is most probably used to determining the viscosity. Capillary viscometer. First point. Oswald viscometer is most widely used in capillary viscometer method. Second point. It is also known as U-tube viscometer. Third point. Oswald viscometer is most widely used for Newtonian fluids. Fourth point. A Newtonian fluid is defined as one with constant viscosity with zero shear rate at zero shear stress. Oswald viscometer or viscometer is an instrument that works on the principle of Poisson law. As per Poisson law, in the case of a laminar flow of the fluids, the flow rate of liquid can be denoted as the ratio of pressure difference with respect to the viscous resistance. Construction. A viscometer is usually constructed in the shape of the English alphabet U. The material used to construct a viscometer usually preferred to be glass. The wider limb of the viscometer is located on one side of the viscometer capillary tube and is used as the opening from which the fluid whose viscosity is required to be measured is poured. An Oswald viscometer typically consists of two bulbs that are attached to each other with the help of a U-shaped tube. One of the bulb is connected to the wider limb on one side and the U-shaped tube on the other side. The second bulb is connected to the capillary tube on one side and to the rubber tube on the other side. The second bulb consists of two markings on either side. The main purpose of the two attached marks is to track the limit of the flow of the liquid through the capillary tube. These markings are generally denoted by upper mark A and lower mark B. The second opening of the viscometer tube that is attached to a rubber tube is used to suck the liquid inside. Working. The working of an Oswald viscometer is quite simple. The U-shaped glass viscometer tube is held vertically still. The first step is to pour liquid into the capillary tube through the wider limb or the pipette. The fluid is allowed to flow through the tube freely. The liquid is poured into the tube till the bulb 1 gets properly filled with it. Once the bulb 1 gets filled with the liquid, it is sucked from the other side of the tube. The liquid begins to travel from bulb 1 to bulb 2 through the U-tube. Once the liquid manages to reach bulb 2, it is made to flow freely inside the capillary tube from the upper marking A towards the lower marking B. The time taken by liquid to flow from the upper mark to a lower mark is noted with the help of a stopwatch. This time is then used to determining the value of viscosity of the liquid. Formula. The formula used to determine the viscosity by Oswald viscometer is as follows. N1 is equals to rho 1 into T1 upon N2 is equals to rho 2 into T2, where N1 is viscosity of the test liquid, N2 is viscosity of standard fluid, rho 1 is density of test liquid, rho 2 is density of standard liquid, T1 is time taken by test liquid to flow, T2 is time taken by standard liquid to flow. On rearranging, we get N1 is equals to rho 1 into T1 into N2 upon rho 2 into T2. Now put all the values in above formula and determine the viscosity. Advantages. Measure precise viscosities for many diverse fluids, small and portable, inexpensive, easy to use. Disadvantages. Difficult to clean the capillary tube. No single tube is suitable for all viscosities. Basic model can only be used for translucent fluids. That's it for today. Thank you.